So in our work, the goal of our work is to develop robotic technologies that can be deployed in real-world scenarios with in social contexts, so to interact with people. And like if we look at movies, which typically give like a good representation of what these future technologies should look like, we see like robots that are really good at interacting with people and understanding them and adapting their behavior based on the environment and on the people. So like if we compare this with the current state of the art, instead we see that like we have, yes, very good kinesthetic abilities in robots, for example the Boston Dynamics robots, but if we look at the way they can understand people and interact with them, it's typically pretty limited, and also the adaptation to the situation and to the environment is also quite limited. So one thing that is missing and that we're trying to solve like with this work is basically to have a better understanding of the people and then use this understanding to adapt the robot behavior. So the scenario of this work is a public museum in Lincoln where we have this robot, Lindsey, which is deployed to give guided tours to the visitors of the museum. The museum is free and people can just enter, interact with the robot, leave, start a tour or stop a tour, or just leave at any moment during the interaction. So the robot provides guided tours, which there are 4 of them with different themes and different items in the museum. And they are in different locations, so the robot must guide the people to the location of the item and then describe it, and it can give different level of details. So the robot has been there since 2018, and he has, in long-term deployment, he has traveled for 1,000 kilometers and interacted with hundreds of people. So during this long-term deployment, the robot was following a static behavior. So it was describing the tour at the beginning, then going to the first item, and then asking the user if they want more detail about this item or going to the next one. And so like it was a pretty static tour, and it can be like summarized as a sequence where you go to the first item, the second, third, fourth, fifth, and so on. So like one thing that we can change and we can learn from experience is basically to try to infer when people would like to have more information about a certain item, and when instead they just want to continue to the next one. So according to the state at the moment during the tour. So again, like another thing that we can change also is basically the sequence of the tour. So that the robot observing the users, it decides which items to go based on their state. So for example, at the beginning you can go to the second item and then go to any of the remaining one, and basically you can have like many different tools that the robot can do for like the different behaviors of the view. So again, like if we take back those 2 components and we put them into the context of the robot in the museum, so now we have this robot that is interacting with people and it's providing some states about its users, about the environment, and about the robot itself. And the computation basically needs to provide an action that the robot needs to perform. So in order to get a better understanding of the state of the people during interaction, we use an engagement model, which takes RGB frames from the robot camera and provides a value of engagement. So this model is a trained model, which was trained from data in the museum and manually annotated. And here, basically, the frames are collected in a window, and the output, that is the input, and the output is a value between 0 and 1. So here we have 3 examples of low engagement, where, for example, the user is looking somewhere else in the, which is not in the context of the tour, or medium, when the person, for example, is still looking at the robot but taking a picture, for example, so it's still somewhat engaged with the tour, and high when the person is looking straight at the screen of the robot, for example. So then, for adaptation, basically we use the engagement value that we get from the model, and we use a reinforcement learning model. And the engagement value is basically fed into the observations and into the reward. So in this way, the reinforcement learning is basically maximizing the reward, which is the engagement of the users. So the motivation for doing this is like to validate our first hypothesis, which is that people that have higher engagement, they want to interact more with the robot. They want to have longer tours probably, and they want to stay more in the tour and interacting in it. And the second hypothesis instead is basically evaluating whether people that display different level of engagements during the tour, they prefer the tour to actually be different and to have the robot perform different actions. So for our reinforcement learning model, we use the upper confidence bound value iteration, which is an episodic algorithm and is based on the principle of optimism in the face of uncertainty. And this optimistic approach allows us to efficiently explore while managing, efficiently manage exploration and exploitation. And this choice is really important in scenarios, for example, social robotics, where you don't have a lot of experience you can take from for learning. For example, we know that in all the months of deployment, the robot has explored really well with the static tool a specific state action space, and while the rest is completely unexplored. And our algorithm, what we do is basically push the exploration toward one of the other areas that have not been explored yet. And so when then it will start exploring one of those portions, then it will keep exploring that until it becomes good enough, and then it will go to another portion again. So this is much more efficient than performing random exploration, for example. Okay, so then we put this framework into the robot to act in the real world scenario. And here you can see the view from the robot camera and the detection of engagement, which is performed online. And based on that, the robot is deciding the action. And then at the end of every tour, the robot is updating its policy with the data that it has collected. So the evaluation is then performed in 3 different phases. So the first one is the one with the static tool, where the robot is always performing the same behavior. The second one is when we actually put our learning framework, and the third one is a validation phase. So the difference in time between the static and the learning phase is basically the COVID lockdowns, so the museum was closed, and the validation phase was useful to actually test whether the difference in the results are actually due to the learning of the robot behavior and not from a difference of how people behave or how people want to behave with a robot after, for example, the COVID pandemic, which may have affected the way people behave. So then here we evaluate mainly 2 metrics. The first one is the average amount of stops that the robot perform in the tours per week, which is the green bars, and below we have the success rate, which is the rate of tours that were completed until the end. So the robot has navigated to all the items in the tour. And here we see that there is an increase, and if you compare the average, the increase is more or less 22% and 30% for the 2 metrics. And we see that during the validation phase, the value are back to compare with the static tour. And this confirms our first hypothesis, that users, if you maximize engagement, users will want to stay more during the interaction, with the robot. So the second hypothesis can be instead tested by unrolling the policy and fixing the engagement value at different levels, so high, medium, low, medium, and high. And basically here we see what the robot will do in those 3 different conditions. So for low engagement, here we see that the robot give less details about the items, and as we increase the engagement, the robot basically learn to give the maximum amount of details about each item. And this is confirming our second hypothesis, which people that are displaying different level of engagements, actually they want to perform a slightly different tool with the robot, and that can be learned, for example, with our framework. Thank you very much for attending my presentation, and I'm happy to take any question or to talk with you after the session.
Thank you. If you have any question, please come up to the microphone so we can all hear you.
Sorry, can you repeat the first part?
So it looked like you rated the evaluation of the robot based on how they interacted with the robot. But I'm wondering if it's not better to maybe evaluate how they interact with the exhibit. Like if they look at the exhibit longer or something like that. Just curious.
Yeah, so basically like the evaluation is the amount of time that people stayed in the tour. And we use that as an indicator of people actually enjoying the interaction with the robot and wanting to know more about the items in the tour, for example. Yeah, because it's difficult to, like the robot during the tours was also displaying some additional content on the screen on top of what was in the museum already. So it was difficult to evaluate exactly like if people were actually interested in that, like by looking at where they were looking, for example. Yeah.
Thank you very much.
Thank you for the work, right, quite nice. How did you handle the data security and safety issues regarding personal data?
Yeah, so
you collected a lot of facial data currently, or gaze directions, which is in theory all personalized data.
yeah, so that that fell in part with the CCTV regulation of the museum that is already in place. So there are already CCTV cameras in there, and also like all the data that was collected is like can only be used by us for like research purposes. So that is the restriction. So we cannot release any data set. And yeah, the video that I showed here at the presentation, we got specific like permission by the people in the tour to actually being recorded.
Thanks. I've got one question. One is, how does this fail? What happens when people just don't want to engage? What is the out button? And the second is, how did you deal with those cases in your data set?
So yeah, that's just part of the data that the robot is learning from. So people will either actively stop the tool because there is a button which says stop tool, so they can just press that and just stop it. Otherwise, they can go away and then just leave while the robot is still talking to no one. And yeah, that's part of the data that the robot learned from.
Yeah, thank you for the talk. Question about the collisions. How to handle it's potentially dangerous environment, dynamic environment with many people, and are they moving in front of the robot, and how to handle that?
So like we have a navigation stack that tries to detect obstacles and avoid them. Also, like the robot is like the base of the robot is encircled by like bumpers. So every time it bumps against something, it just cuts the power of the motors. So it cannot navigate anymore. And so yeah, it is way like and also the robot is quite. I don't know if you saw the picture. It's quite like safe. It doesn't have any arm or any like yeah, dangerous part that can hit, and it also has emergency buttons, so that's another thing that the users can press.
All right, time for one more quick one.
So one more thing, a lot of robotics in these areas should, in theory, help the humans in the space. So did any of the information you extract there feed back to the curators of the museum? And is there something they can take away for making the museum a nicer, more interesting, more engaging place? Or is that like, was everything optimal really, and you couldn't learn that skipping was some exhibitors? Yeah, some items make sense.
Yeah, so like we collect this statistic because it's a very long-term deployment. So like we collect a lot of data on like which days people interact in the museum, which item they go to, and we give those like summaries to the people, to the managers of the museum. So I don't know exactly how they use it, but yeah, like they are really interested about this, and they are really happy to continue having the robot there. So I guess that's a positive thing for the deployment.
All right, thank you for an interesting talk.
Thank you.
Thank you.